Hello everyone. I hope you all are enjoying the event. I am Ammar Solkar and I'm here to talk about my project, which is last mile delivery robot for residential buildings.
So, you must have seen or heard of robots making deliveries by now. Several companies are now making robots which are delivering food, groceries, packages, and a lot of stuff to our homes. But the thing is, these robots don't exactly cater to people living in apartment buildings. If you live in an apartment building, you would either have to go to the lobby to pick up the package or you're out of luck. Well, it doesn't have to be that way, and that is what my project is about.
So I made a virtual robot using ROS and simulated it using Gazebo, a popular physics simulator. The functionality of the robot goes somewhat as follows. The robot is dropped outside the building or in some pre-specified area. Why this constraint, you might ask? Well, it's because it makes it easier for the robot to figure out where it is in the world. The robot is given the details of the delivery to be made, that is, the building name, the floor number, and the room number. The bot already has the map of the buildings and it gets it using the building name given to it. The bot calculates the path it will need to perform the delivery and gets on its way. The bot navigates through the lobby of the building and reaches the elevator. There, it sends a request to the elevator and waits for it. Once the elevator doors open, the robot gets in and sends the required floor number to the elevator. The elevator then takes the robot to its floor. Once the required floor is reached, the bot moves out and goes to the required door. It stops in front of the door, checks the number plate to verify if the door is the correct one, and if it is, it drops the package in front of the door. The package is now delivered. A picture can be taken and confirmation can be sent to the customer. The robot then goes back to the starting area it came from and waits there for the delivery van to pick it up for the next delivery. So let's talk a bit about what is required for the bot to be able to do this. The apartment building which is being targeted will have to be mapped once prior to running the deliveries. This will require a personnel to accompany a robot or a mapping device to map out the floors which have fundamentally distinct structures, like floors and lobbies. These maps can then be reused for areas which have similar structure. For example, most floors will have the same structure, so it is not required to map all the floors, just all the unique ones. This will save time and money and make the process easier. Once the mapping is done, the building can then be eligible for autonomous deliveries. So, whenever people see this project, the one thing that comes up is okay, Amar, this sounds good, but how can we implement this in real life? How will the robot interact with the elevator? Well, let's consider two extreme ways we can do this. The first one would be to attach a manipulator or a robotic arm which is capable of pushing the buttons. But if the robot is to move around humans in cramped spaces like elevators, I personally don't like this method. The other end would be to have the buildings be fully IoT enabled, continually talking to the robot, taking the robot where it wants to go. Take, for example, the robot comes to run a delivery. The robot says, "Hey, elevator, take me to the 20th floor." The elevator goes, "Sure, buddy, come on in," and waits for the robot to come in and moves to the 20th floor. This, in my mind, would be the ideal case, but we are not really there yet in terms of technology adoption. So, how do we implement this? Well, we can either wait for the technology to become mainstream and then start building these applications, or what we can do is start by retrofitting elevators to work with IoT, creating the demand for IoT enabled elevators and buildings, and pull the tech with us. Either way, it's going to be exciting because someone is going to figure it out and it will be really cool. And that is my presentation for today. If you want to learn more, you can check out my GitHub or LinkedIn. Thank you.